Thank you, everybody. Welcome back to another episode of the InterDrone Podcast, your 30,000-foot view of the commercial drone industry. My name is CJ Smith with the InterDrone team. I am joined today with my colleague and InterDrone's chairman, Michael Pehel. And we have two fantastic guests with us today on this Tuesday afternoon. We are joined today with Sally French, aka the Drone Girl, and you can read all of her incredible writing on thedronegirl.com. And we're going to jump into a couple of articles of hers in a minute. We're also joined today with Paul Wheeler. He's the Unmanned Aircraft Systems Program Manager for the Utah Department of Transportation. So, yeah, thank you guys so much for being here. If you guys wouldn't mind just briefly giving the audience an introduction just about the work you do and kind of how you work in UAS.
Sure, CJ, you already gave me a great intro, so I don't know what I can add more to that, other than I love everything about the drone industry. My site does everything from news to reviews, tips, answering questions, everything from what drone should I buy for my kid, because I want to get my kid interested in drones, to today I have kind of a spicy article about made in USA drones. People are really curious about which drone companies are even based in the US, and especially with potential rules around governments saying you can't fly drones that were made in China or made outside the US. That's kind of hot topic. So those are just a couple of the things I write about.
Yeah, awesome site, Sally, by the way. I got to commend you on all that you're doing. That's great. I was looking at your site and it's just like, oh, this is neat. I needed this a while ago and I didn't even know about it. So that's great. I'll have to share the information around. So as CJ was saying, the UAS and UAM program manager here for the state of Utah. And I just get to have a lot of fun, really. I'm also an instrument-rated pilot, too. So I get to fly the manned aircraft and the unmanned both. Cool. But really what we're looking at is what are the ways that we can utilize these? I have a huge passion about these. I grew up flying RC stuff, loved aviation since I was a little kid. And I try to propagate that out on how we can use it, what sensors we can use, what is possible with using UAS. And that's what kind of got us started and why we're doing so much with them, because it's such an amazing tool and we're saving lives with them. We're able to save a ton of money on taxpayer things, and it's just a great tool for everyone to use. So
great. And if anyone is just tuning in for the first time, the format of this podcast, we discussed a couple articles from the past week that are particularly interesting, relevant to commercial drones. And we then shift into the interview portion of the podcast where we will do a little bit of a deep dive with Paul and ask him about some of the stuff he's doing in Utah. So without further ado, the first article on the list today is written by Miss Sally French. Delivery drone pilots prefer manual drone flights to autonomous ones. So this is actually picking up on an article that we spoke about last week, I believe. So DroneUp went to a vacant college campus in Virginia. And what they did is they actually essentially treated the campus like a small city. You know, every college student is at home due to the pandemic and summer vacation now. But they treated the campus like a small city and really tested soup to nuts drone delivery. What's possible, test everything, let's measure everything, and let's get some insights. In particular, the article that you wrote about and what we're discussing right here, Sally, is that these pilots, they actually preferred manually flying, and in some cases, the delivery times are actually significantly cut down with manual flight. Sally, if you wouldn't mind just kind of picking up on this, what were some of the big takeaways that you came away with when doing your research and when writing this?
Yeah, totally. Thanks, DJ. I was talking to DroneUp about how all these tests went. They're testing drone delivery through all sorts of factors, and they did sort of like all these A/B tests. And something that really just stood out to me was this test of flights of humans piloting them and the robots actually doing the work. And so, as CJ said, the humans piloting the flights often move faster. The reason why is because human pilots actually fly faster. The manual controls are set to have the drone fly a little bit slower. And I do wonder, over time, as the robots get smarter, if the robots themselves can actually fly faster and catch up to the human pilots. Of course, the big differentiating factor is human pilots were less consistent. So in a case where you have to fly the exact same route, and I mean, down to the inch, then a manual drone is always going to do it better. But what really stood out to me is what the report actually said, is they sort of kind of analyzed this whole phenomenon, and it said that there's resistance to the black box effect, where pilots don't know what the software is doing and they don't trust it. Right. Part of it is an ego thing where their skill is on display if they are flying, which I thought was so funny.
Yeah.
Paul, I'm sort of curious, are your flights primarily human piloted or are they manual?
So yeah, I'd say both. And it's interesting reading that article that you had with that, because I see the same thing in certain areas. So for instance, like doing a bridge. When you've got to fly around a bridge, automation is an absolute no-no, right? You're going to run into the bridge using automation typically. Even with the sensors, especially when you get underneath, you lose GPS. So you've got to fly manually. In fact, I tell most of our pilots, the way we train them is to fly without GPS or in ADI mode, depending on the aircraft they're in. That way, it's not a surprise when it suddenly disappears and the wind's blowing and you're getting close to running into something, right? So I could see the manual aspect of that. Now, for mapping, when I'm out mapping, there's no way I can fly a consistent map perfectly with an overlap. It's just nearly impossible to do. You can kind of do it, but as you said, you weave in and out. It's not exactly a good grid. So for that, I love the automation, even though it's like watching paint dry for some of the bigger missions, right? But you get a more consistent product out of that.
I am sort of curious about drone delivery. It's sort of like this hybrid. If I hear the bridge example and I hear the mapping example, those totally make sense. Right. And drone delivery, I guess it could go either way.
Yeah, where I see though on delivery though, when you think about all the aircraft that come into the sky, you almost have to have automation, right? Because if you look at the accident rates just with cars, then how's that going to work when they all go into the air? If you look at aviation safety record versus the automobile safety record, it's much better, right? Last year, unfortunately, over 37,000 people died in automobiles. And that's also my argument why urban air mobility might be awesome, because in aviation, I mean, safety record's a lot better. I think it was last year they had one commercially fatality. If you look at all of general aviation and aviation, I think it was somewhere around 300 or so. But you look at the 37,000 in an automobile and people are like, oh, I'm scared to fly. Well, you should be more scared to get in your car, right?
Yeah.
And where are those accidents in general aviation? They're probably smaller planes, right? Individual operators, less sophisticated autopilots.
Yeah, absolutely. But I think the key is when you get all those aircraft in the sky for drone deliveries, they've got to be somewhat automated because there's going to be so much traffic. We've been working on a simulator testing all that in coordination with the University of Utah, seeing what happens if we put a vertiport here versus one here. How many aircraft can we have in the sky? What happens if we put corridors here? And it was interesting. If we just let everybody fly wherever they wanted, the system broke down really fast. Yet if we had highways in the skies, we could do a lot more efficiency and it worked a lot better. But with that, it kind of needed the automation for how do you coexist when you have the package delivery layer and then you have an aerial passenger vehicle layer. So for those to coexist and be able to fly around each other, they need to be able to talk each other, to see each other, know where they're at. And could you do it manually? Probably. But once you lose your eyes and you're flying from somewhere else when it's a longer distance, I think that's where the things change. If you can see it all the time, it's probably easier. But what happens when you're 5-10 miles out and you can no longer see the aircraft?
Yeah, I think it will be a game changer when things like Skydio become more prevalent, where you have all these sensors and drones really can avoid crashes. I wonder if that will give people a little more trust in the robots.
Yeah, I was thinking about this the other day when I was driving my car because somebody, gave me the wave to go, right? So that's a form of deconfliction. And that's not actually possible if you have multiple pilots piloting from a distance, right? There's kind of like, any simulated view is more restrictive. It's a two-dimensional representation of space. So in order to scale, you have to have that automation. So egos will have to be, I guess, couched.
Mike, I love what you said about the egos, because I think ultimately that's what it really comes down to, is we all think we're smarter than the robots.
Yeah.
Well, yeah, and there's certain times too when you're manually flying, just it looks different, right? You might think an obstacle may be further away or closer than it really is. And by utilizing the sensors or cameras, you can kind of see better and using all that situational awareness. But again, some of those areas are hard. We'll have visual observers with radios helping out on that for some of those complex things. So at the package delivery, if you're trying to weave in and out of some areas, like imagine trying to fly through New York manually around some of those when your eyesight's limited. So that's where I see some of the automation and mapping. And that's probably where it's key to have a lot better data, which the drones can provide, right? We get better maps. We know where everything's at. And then the automation can take place because it's only really as good as it's programmed, right? As it's said in there what people are scared of. But as long as we're programming those elements into it, I think that's what will help. And we probably have a long way to go and a lot of things to learn. But the way we progress so far is amazing, right?
Yeah, it's interesting thinking about navigating an urban environment. If anybody's ever been to New York City in the winter, you could go down one street and just because those buildings are taller, the wind gusts down that kind of tunnel is so much worse. So these are the type of calculations we haven't even thought about, which we'll be confronted with when we start to scale and move into, I guess, more dynamic environments like cities.
Totally.
Yeah. I mean, the findings, the accuracy of the delivery, the machines definitely did it better. I do think it is funny that the flight speed was higher with the manual pilot. I wonder if that's, if because the autopilot is programmed to really take safety, make safety paramount, fly a little slower, fly a little higher, do everything you can to make sure at all costs you're not going to crash into something, while here the manual pilots are kind of pushing those limits a little bit more, which is
I could use an extra, it took a dangerous turn that you might not take if you were taking all safety into account, right?
Yeah, totally. And you're even right about they're flying higher, which requires the flight time to be longer. Obviously, it takes more time to go up higher and come back down lower to do the delivery. So that also, plays into the battery consumption as well, as if drones are flying higher and their flights are longer, maybe that's not a good thing if the battery consumption matters so much. Right. So it's definitely an interesting debate.
Yeah. I think just one last funny thing to note, we had Chris Anderson on last week, and he was at a high level talking about the drone industry. And he's saying we right now it's essentially one pilot to one drone. We haven't really created any economies of scale yet. He said it's really a remote control helicopter industry, which he's being, I think, a little bit tongue-in-cheek.
He flat out said it wasn't drones.
It's remote control helicopter industry. And so it's just funny now, here we are again, the pilots prefer to fly one-to-one, and then essentially, we're not really achieving this great economy of scale. So back to the Eagle argument, you just wonder how all that stuff kind of plays out. But
the only one I can think of that's like really a good example of not this is the Intel light show drones, where it really is like 4 pilots and then 4,000 drones or whatever. But you're totally right. Other than that, it seems to be a remote control robot industry.
For now, but you got to start somewhere, right? So.
Absolutely.
Great. We're let's shift into our second article, and it talks a little bit about UTM actually. So this was last Friday. The DAC, the Drone Advisory Committee, met, and I think the takeaways, mixed reviews. Some people are saying there wasn't too much kind of substantial rulings or any information that really came out that was groundbreaking. Elaine Cho, the U.S. Secretary of Transportation, she emphasized the need for safety first in the drone industry. Some of the areas of, quote, full support that the task force listed in their agreement is a federated UTM system rather than a single government-provided system. They also mentioned the benefits of Lance and the need for standards development, the concept of government qualified services and service providers. Did any of you guys tune in, or what are some of the kind of main takeaways that you guys had from the DAC meeting?
Yeah, I did tune in, and it's kind of interesting. More and more stuff is happening online now, and it's great that the FAA is opening this up for anyone to listen to now. And I think we have coronavirus to thank for that. Not a lot of good things that came out of coronavirus, but I think opening these government conversations to ultimately we're just regular people, and that we get to participate, I think is really neat. And I would encourage anyone to listen in if they can. It's still, you can watch the recap on YouTube.
Yeah, that kind of is an awesome effect of just COVID in general, kind of breaking what for some people was a generational thing too, right? We always did it in person. This is how we always do it. But once you're forced to get online, and you're like, oh, this isn't so bad. I could do this all on my own. And just being forced to get there, watching pretty kind of ancient institutions finally kind of move digitally. It's awesome because this is where, democracy can actually participate on a level that it didn't in the past.
Mm-hmm.
You'd have to show up for the town meeting. Right now it's broadcast and you could comment on the Facebook page.
Yeah, it was just like eating cereal and watching it was nice. And they actually got very fancy. They had matching Zoom backgrounds that all said like FAA or something.
Oh,
and
that's cute.
on the Zoom call had like the same background. I was like, wow, they're very coordinated.
Yeah.
But I think the big takeaway for me was that they said that they expect to issue a final rule on remote ID in December of 2020. That was probably like the meeting in a nutshell is the most interesting thing.
Mm-hmm.
What were your thoughts, Paul?
Yeah, I would agree. It's exciting to see that date on there. I know a lot of us are waiting in anticipation for remote ID to come out. Also, what I really liked was them talking about the federated UTM system, because I think that's imperative. Because can you imagine if every city had their own regulations? And if you're a company trying to do package delivery, how hard that would be if you're trying to figure out what every rule and everything is for every different city or state. It would be quite difficult for that. So I think that federated system is imperative for that to happen and to really make it flow and make it efficient, right? And that culture of safety too. I love them talking about that because really, as you guys know, there's a lot of bad publicity out there about drones, right?
Yeah.
It seems like it's always getting publicized when somebody does something stupid, but it's good to see what you guys are doing, what Sally's doing, and putting out the good things that drones are doing. I think if we can do more of that and showing how they're helping people, how they're changing the way we live, just like what you're saying with technology. I think the drones are doing the same thing. They're taking us into kind of a new era of data collection, right?
Mm-hmm.
In different pieces.
On that safety note, Brendan Schulman, he's a representative for DJI, so of course he does have like an incentive to make DJI look good. But he did talk about how good of a drone record or safety record drones have, and DJI was able to cull together data that there were 87.8 million drone flights in 2019 in the U.S. alone, and that totaled 10.3 million flight hours. So if you're trying to do math in your head, that's like a 7-minute flight per drone, which makes sense. But I thought it was really interesting that Brendan pointed out there are not drone crashes for 10.3 million flight hours. There are not drone crashes. It just really illustrates that safety culture.
Yeah, and every kind of month that goes by, one of the interesting things about remote ID was it was originally positioned as a necessity for that safety, whereas now I think it's being positioned as more of a necessity for us to scale safely. And I kind of wish that was the original kind of couching of the argument and need for it. It's less paranoid, and on top of that, it kind of helps us craft the rule better, right? Mm-hmm. Even as thinking about what we need to consider. I think we're all waiting for remote ID. It's nice to have a date on it. Let's hope to keep to it.
Yeah.
But yeah, I guess this was just kind of one step that we were expecting to have to take. And it's over now, so we can move on to the next thing, which is actually having a rule on the record. Right. I think we're all excited for that.
Yeah, one other thing, too, that I thought was pretty interesting was just saying tech neutral, right? Because I think that's another very important thing, because how fast technology is changing, I think that's extremely important, because if they limit the innovation that we're going to have in this, it's going to probably make it fail, right? But if they keep it flexible and keep it tech neutral, I think that's what's really going to make it succeed, because so many things are being invented. The innovation that's coming out of our day and age is just amazing right now. So why limit that, right? We got a lot of smart people working on this.
Yeah, and they haven't even caught up with the technology as far as figuring out what it all means. Chris Anderson has said in the past, and then Ramon from Drone Code also has said this exact phrase to me, which is everything that you see a drone can do today, we were able to do 10 years ago.
Yeah.
Right. So think about that, where really the issue is informing all the humans involved of the exact extensiveness of all of those capabilities, and then kind of formatting what we feel is safe, what we think works, formulating data about that, and kind of sharing that data among each other so we can define what a safe and legal operation looks like.
Mm-hmm.
I'm curious, Paul, on the federated system, because you seem really excited about it. How does that compare to traditional aviation? What for our listeners? What's the difference between traditional air traffic control and a federated UTM system?
Right. Well, right now, if you think about the way the system is working on your air traffic control, you're handed off to different controllers, but it's all within the same system, right? So you're going from state to state, you're being handed off to different air traffic controllers who are helping you along, but it's all one system. They all talk to each other. What happens if that system didn't talk to each other? What if one state wasn't compatible with another state and suddenly it broke down and then you're not able to talk, right? Imagine how that would impact the safety record. So I think that's why we see such success right now in traditional aviation, is because how well and how efficient that flows, because of the handoffs there. How it's a pretty well-oiled machine. When you look at all the flights up in the air that we have right now,
and it was all
see how
radar
efficient it flows. Yeah,
not that long ago, right? So when you say passing state to state, it was literally like, okay, it's in your zone now, pick it up.
Right. Same reason why they're using Zulu to them, right? Because they're flying far and they need one system. So that's the kind of the way that it would work. Now, if you think about the drones, I mean, back in, January 2018, it was a 5-to-1 ratio of unmanned to manned, right? It's probably a lot more than that. I haven't seen the latest figures on that, but take 5 times the amount of aircraft that's in the sky right now, and imagine if they had to work independently with every state, it's just going to break the whole system down. So it really needs to be one system. Now, who controls that might be different. So maybe they're having different people help on that system. Maybe they partner with some states to help with that system. Maybe it's all on the federal side. We're not sure where that's going. I've heard talk on both ways, but as long as you're using the same system for everybody to fly, I think that's the key. So everybody can talk to each other, they can see what's happening, and it just makes it a lot better and easier to work on the policy framework and to make that happen. I know sometimes it will just be intercity, so it may not be that big of a deal, but when you start going interstate, that's when it's imperative probably to keep that system that way.
Mm-hmm.
When I think about the benefits of anything being federated, I think of this I think it was a Nat Geo documentary, or no, Discovery Channel documentary. And it was talking about the Confederacy or the Confederate Articles of Confederation at the kind of the birth of America, and how that kind of gave states' rights so much extra power over a kind of federal unifying principle. And they said, imagine driving to New Jersey and having to use a different currency at the toll.
Right.
And then you kind of understand the power of having kind of back-end systems and protocols for communication, transportation, unified. It allows us to actually be so much bigger than we are individually as states. So that's definitely applies here, if not more so.
Right.
Yeah, and if you look at even on the roadway systems now for traffic operations centers, right, they don't tell people where to drive and where to go. They just let you know of what's happening. And I see that with automation in a UTM system. They'll just show where everybody's at, and it's the own manufacturer's responsibility to get the routing and everything else in there at some point, right? You can tell them, okay, you need to take this path or this path, but they're going to put a safety message more than likely out there to warn everybody. Say like something happens and you need to do a TFR or temporary flight restriction. You warn everybody in the system, then the automation can route around that and make it a lot more efficient, right? So I think that's where that's key to have one system in there so everybody can talk. And maybe that's different software systems that tie into it, like the Lance works. But as long as it's tech neutral and it can all talk to each other, I think that's the key.
Mm-hmm.
And quick follow-up on that, Paul, just for clarity. So what happens internationally? Are there different UTM systems that we need to communicate with each other across country borders? Just like, like we're saying states would have to, we want to avoid that. But what happens when you get outside of your domestic territory?
Right. Yeah, that is a problem. If you look in Europe right now and the UTM systems, there's a few different ones. Some are more integrated into other the countries together as one. But I think they're going to have some issues with that if they don't talk to each other. As long as you have a framework that can consistently talk, I think it'll be okay. Right now with our battery technology, we all know we probably can't fly across the ocean, but if you're getting into hydrogen and other things, we might be able to. Or if there's a new breakthrough in battery technologies, then that may change and we might be able to do those international deliveries. And that's where I think it becomes imperative that maybe we do have one system that can at least talk. If you look at just the phraseology in talk in aviation, it's that way. The systems are different, but they know how to talk to each other across the entire world.
Or even, international, thinking more locally, across the Great Lakes, if we're able to extend battery life by, 20 to 30 minutes, we could probably do flights, delivery flights between here and Canada.
Mm-hmm.
Yeah, absolutely.
So what's next, CJ? What do we got?
We have one more article from Sally, and then we'll jump into our interview with Paul. So this article is talking about DroneBase. So aerial data analytics company DroneBase received $7.5 million in Series C funding with the idea to expand its services to the renewable energy market. One note is that one of the investors in DroneBase was DJI. Mm-hmm. So I think what's kind of interesting is that we're seeing the renewable energy market grow, right? We're trying to reduce the use of fossil fuels. There's all sorts of different type of energy sources that we're focusing on kind of as a world. And in particular, this is talking about turbines and windmills. And they're saying that at offshore wind farms in Europe, they could save $1,000 per turbine per year in inspection costs, and thus reducing the cost of producing electricity by 1%. So 1% may not seem like a lot, but when you're talking about that level of scale, I think it's a significant amount of money. Also, just to note, wind power generated 5 times more electricity in 2018 than it did in 2008. So, who knows? In the next 10 years, we see another 5x. But on a global scale, wind is still only 4% of the world's electricity supply. So, I think it's just, we're seeing an increase in use in renewable energy. We're seeing an increased use in drones for inspection services. And so we're kind of seeing both those forces converge here. What are some of your guys' takeaways from this?
Yeah, I haven't heard, a ton about drones and renewable energy. You hear it every once in a while of people talking about like drones could be used for an inspection purpose. But it seems like really the stories that you're hearing are drone delivery, drones in agriculture. And so this just sort of stood out to me as like maybe we're actually looking at renewable energy now. The fact that this company, they raised $7.5 million, which means their total funding is at $32 million, which means that that's a significant amount of money being devoted to wind inspections specifically. Right. I mean, that's like totally the future we're in right now is talking about renewable energy. So I'm glad that drones are helping propel that future forward.
Yeah, I thought it was interesting. Oh, go ahead.
No, you go, Paul. You're the guest.
Oh, I was going to say, I think it's pretty interesting how they talked about the winds. So your high altitude winds, you can get up a little higher and take advantage of those where you're not always able to in other places. So I think that was pretty interesting for me to hear about that. And then getting 100 times better global energy from that. So, right? I think that's what they were saying. Wasn't it 100 times if I recall right?
So what's sort of interesting about drones in the renewable energy area is that like they can be used for inspections of wind turbines, but in a way a drone could be a wind turbine itself. Drone or any sort of wind turbine generates more energy at a higher altitude than a lower altitude. That's why you see wind turbines up in the mountains. When you're driving over the hills, driving up to NorCal from SoCal, you see those wind turbines up in the hills. And so there could be a future where drones would actually be flying up in the air at such high altitudes. And they could be, on San Francisco, which is like a zero altitude. We're right on the water, but still be generating electricity because they're flying up in the air. I think would just be such a fascinating future. And we're not there yet. Google is researching it through their arm Makani. And I think that's way far out in the future, but definitely something cool to be hopeful for.
So I was going to say it's interesting to see $7.5 million being put into the drone industry right now at this moment in history. So we kind of saw closing off of funding during the month of April, but we did see some funding rounds in May, and this is kind of one of the bigger ones on the docket. And to your point about $7.5 million out of $32 million raised, it's a significant chunk to put towards a completely new initiative too, right? This is not what Drone Base was kind of made for. So,
right.
I question whether or not they think that they're able to do completely revamp things on that budget. I mean, they had to make that case, I guess. Or for this new initiative. Are they going to continue their older initiatives too, or is this going to be the main focus? Yeah. And I think we're going to see a lot of kind of just interest in general from drone companies in redefining themselves in a post-COVID world. If you survived and didn't have to close up shop after the pressure of the last 3 months, figuring out who you're going to be in the new world, I think gives you a lot of latitude to make successes quickly, because people are going to be looking at automation, maybe not this year as much because there's just less money around, but definitely 2, 3, 4 years from now, because we've all been kind of we've received the same trauma, and we're thinking like less humans might be good in some areas where we wouldn't have said that maybe a year ago.
Right. The coronavirus point is really interesting. I mean, this is clearly a coronavirus-proof investment. The job itself of, flying drones to inspect wind turbines, that takes one person to set off the drone. And it is sort of a solitary job. So I'm intrigued by that. Also, we always need power, and we always need cheaper power. And we always need cleaner power. And so, I see a lot of these companies that are folding because they make camera drones, and if people are unemployed, they don't have money to buy, foofy $500 tech toys. But, we're always going to need wind energy, right? Now more than ever. So I think it's a smart investment, and I hope it pans out.
Yeah. And, in some cases, drones are always about optimization, right? And when they're not, like when you're not actually offering, 2x, 3x, 4x optimization, people are more likely just going to use either ground technology or what they're used to. Right. So this is definitely one of those cases. And I think early on it had been said and promoted that wind turbine is a clear use case. Yeah. I'm just happy to see that there's enough traction that investment followed that.
Yeah.
Mm-hmm. Well, and for what it's worth, Drone Base says it increased sales and set new revenue records in March, April, and May. So money coming in from both sides, hopefully. I guess so. All right, guys, we're going to take a quick break, and we'll be right back to ask Paul Wheeler a few questions. Thank you, everybody, for joining us. Welcome back to the InterDrone Podcast. We're joined today with Paul Wheeler. He is the Unmanned Aircraft Systems Program Manager for the Utah Department of Transportation. Really excited to have him here and to talk a little bit about what's going on in the state of Utah. Paul, you gave us a brief introduction at the beginning of this podcast, but if you could just jump back in and tell us a little bit about your career, how you made your way into the drone industry, and then what your day job looks like now, before and post COVID.
Yeah, sure thing. So, like I said, my background's probably started from my dad. He always took me to air shows and gave me a love for aviation, and that's where it really started. And from that, I got into RC aircraft, or even flying, an airplane with a stick. Or not a stick, a string hooked to it. Remember those old ones? So from there, I learned how to fly RC stuff, went to helicopters. And then where it really started with the Department of Transportation is I started seeing the technology get better. And I knew about flying it, but there wasn't the sensor piece to it. We were flying gliders or other things, finding winds and having fun. But we had a project with our Utah State University where they'd built up a UAS and put sensors on it. I went to look at it, and it was home built. It was with duct tape and everything else. And do you remember in school, did you guys ever make those rubber band chains? The big thick ones? Yeah.
Mm-hmm.
So they had one of those to launch this, right? And I'm out in the field. I'm like, this is going to fail. I'm waiting for it to tank it to the ground. But they launched it up in the air. It flew, and it had automation, and it did what it wanted to. They had it hooked to, a digital SLR. They had some multispectral cameras and other things on it. And really, it was about the data. And that's where I'm like, wow, this is really viable. This could happen. And fast forward up to 2016, when technology started getting better, you started seeing more drones come into it with better sensors. I think that was the key. And at that point, we really says, okay, it might be time to jump into this. So since I was already a pilot, we could do the Section 333. I started down that path, but then, as we all know, Part 107 came out. So, and then we seen everything exploding. So I was able to luckily test. My job at that time was to just test out new technologies. And I was like, oh, where do I sign up? Let me try this out. Absolutely. I've got the experience to fly these, and let's see what they can do. So we started just testing out different little use cases to see what was possible. We started with surveying, started with bridge inspection, started with other things, and seen so many savings in and how easy it was to do some of the jobs and how much time we were saving. Instead of setting up traffic control, we weren't impeding traffic. So we use it for little things to really large things, and everything we tried it on worked great. I mean, we have some limitations, obviously. We can't fly over traffic and other things, but what we were seeing is significant savings in the cost of it. And not only that, the safety factor. Unfortunately, if you know the statistics on there, one of the first responders dies about every week in our country from being out on the roadway. And it's just not safe to stand on the road. I started my career out as a surveyor at the Department of Transportation, and you're right there on the road, and semi trucks are flipping rocks at you and everything else. If you think it's bad on a windshield when one hits it, try standing out there. But if you can get out of that environment and still collect the data that you need, that's what really is a game changer for this. And not only that, some of the surveys that we're doing on cliffs, if you've ever been to Utah, it's not flat here. We've got mountains, we've got big cliffs, red rocks, and try and go survey some of that stuff. When you've got a 500-foot cliff, it's not easy to be like, oh, okay, you're just going to go take some shots up there for a survey, right? It's a whole day event if you can even get there, where you can fly a drone and let it map those areas automatically for you, and you're getting better data than what we've ever been able to get. So that's kind of the piece of that. But what it did is, since that grew so exponentially in what we could do, they've seen the benefit of that, and we created a whole UAS program from that. So it wasn't just in the beginning. It's like what even iPhones and other things were. People are like, oh, it's just a toy. And same thing, I bet you've all seen it with the drones or the UAS. They're like, oh, it's just a toy. Why are we going to spend money on toys? But when they seen what the sensors that are attached to those can do, that's what really changed it, and the quality of the data that we could achieve and the ease of use. If you could train somebody to fly them really easily, that's the key as well. It wasn't very hard. The software is good. And that's what really changed things on there for us. And now if you fast forward, 2016 we started, we had 4 of them testing. Fast forward to today, we've got 41 drones in our fleet.
Wow.
We've got 35 remote pilots, and they're out there flying and collecting data. So, and that's just in the DOT. If you're looking at our law enforcement, highway patrol, they've got about that same amount. Our natural resources, our mining districts, other ones are using them too. Imagine trying to survey some of these open pit areas, and when you walk on it, it changes, right? When you're trying to get a shot, and it's not always easy on those slopes, but you can fly them and you're not impacting it whatsoever, and you're getting better data. It's more dense data. So that's where it really comes to play for us. And we see it growing more in the future. Fast forward to the UAM side, that's going to be a huge play too, because as you know, all the cities are getting more and more congested. Traffic's an issue. So how can we combat that? That's the other piece.
So we had Talinda Larson on not that long ago, so we're familiar with the great work that Utah is doing in the UAS industry. But can you talk a little bit more about personal successes that you've had? Just like what are kind of some of your most proud drone moments from Utah?
So one of them, I'd say overhead sign inspections. It sounds pretty lame, but as you know, the overhead signs that you go over, they need inspected. So with that, comes to play. They have to shut down traffic. Does anybody like being stuck in construction or when the traffic lanes close down? Absolutely not. So by utilizing UAS and flying it off to the side of the highway and using a zoom lens, you can zoom in and see all the rivets, all the bolts. So on one project there in Salt Lake City we did on SR201, we saved over $100,000 on that one project alone using UAS versus traditional methods. So they were only able to do typically 2 to 3 signs. They'd close down the road. They'd have to do it at night because they didn't want to impact traffic as much. So they get 2 to 3 signs, trying to crawl around in a bucket truck, trying to inspect every rivet. Yeah. But now we can do it during the day. We're not impacting traffic whatsoever. And just one job alone saved over $100,000 by using drones. So that was a really cool. When I seen that type of money being saved, that was amazing. Or as I mentioned, even surveying, we using LiDAR. We have LiDAR on our UAS as well. And this is down in Bryce Canyon. If anybody's been to that national park down there, we're looking at realigning the road. We had some landslides down there. And it's a lot of hilly area. And it would have taken them about a month and a half to survey that traditionally to get a ground topo. And we were able to fly it with the LiDAR in 1 day. 1 day. We saved a month and a half of time. I mean, you got the processing and everything else, but you're talking 3 or 4 days of time versus a month and a half. And not only that, we're getting a lot better data out of it because it's a lot more dense. So that's
and plus the platform is expandable, or it's extensible. So that's what we can do today. But now that we're using drones, we could figure out new sensors or layering of sensors or higher resolution data, or figuring out ways to interpolate between multispectral and infrared that yield better results, right? So all of that is just an added bonus.
Yeah, absolutely. Another area is like in our incident management. If you've seen the incident management trucks that are out there helping people, we have a drone on every one of those now. And for that, that's say like we have an accident with a serious or fatality, and sometimes the road's closed for 4 hours while they survey that scene. We can get it open in about a fourth of the time by using UAS to map it. Then there's no question what happened on the scene. Or here's another scenario. We had something happen like this not too long ago. Is someone was there's a bad accident. They didn't know how many people were in the vehicle. Now, put yourself in this place. You get in an accident, you're ejected from a vehicle, and you're thrown into an area with a lot of vegetation. This particular area was full of spiders. So nobody wanted to walk into it. There's just spider webs everywhere and spiders, and the highway patrol and people were like, oh, we don't want to walk through there, but we need to find the person. We were able to get our UAS up in the air, use thermal, and search that area, and come to find out there wasn't anybody there, luckily. But imagine if you were the person laying there waiting to get helped and nobody knew you were there, and you're waiting for somebody to walk through all that to find you, where if you were able to find them with thermal and get the help to them, you could easily save somebody's life.
Yeah.
So I have to ask, now you've seen so much success and so much clear success. It seems like no one can deny that drones in this use case are brilliant. But was it always like that? And what, especially in the beginning, did it take to convince the government to adopt drones?
Right. No, it wasn't like that. As I mentioned, it was like, oh, you want to play with a toy, right?
Right.
And then you'd say, okay, well, I got this. Let's see what it can do. And they'd be like, oh, it can't do this job. So we actually had some fun competitions and be like, okay, you do it your way, I'll do it my way, and let's see who gets done faster. But where it really came down to play is when you get them the data and show them what you're able to achieve. That's when it was a game changer. That's when you seen the light bulb come on.
You just being like, I'm going to use this drone, I'm going to fly it, I'm going to do it, or get permission?
So what I would do is I'd go to the different areas and I'd just say, hey, what are you guys going to go do today? And learn about their things. And one instance was in our maintenance division, they had to go inspect fence. And he was just complaining about it. He's like, oh, I'm going to have to go and climb up and down these slopes. Again, the mountainous area, right? And there might be wood ticks out there and other things he's going to have to deal with. So he was going to take all day to walk up and down the slope to just inspect fence. Pretty boring job. I says, hey, why don't we test it with a drone? So I was able to fly the drone 12 miles an hour, a lot faster than anybody can hike. Get it done in, an hour, little over an hour. We flew it, and they've got video documentation. And we're like, here you go. Next thing they're like, we're going to buy a drone. So.
Right.
But it sounds like it really took you just saying, like, I'm going to do this. I'm not going to ask for permission, really. Someone needs to be there and say, we're doing this.
Yeah, luckily, it's they give us a lot of leeway in Utah. And I really got to hand to our management for this is they let us try things. And we have an area where they're saying it's okay to fail sometimes as long as we learn from it. So that's why we're able to test certain things out. And with that, they said, go see what we can do with it. And that's why I was able to do that. And people are more receptive to say, okay, well, let's try it. And, and you get the people like, yeah, right. This little toy is not going to be able to do it. And then when you bring back that data, they're just amazed, like, wow. Yeah. I can't believe you just did that or collected that. And when they look at a point cloud from the data, or just even the imagery of your bolts and other things, that's where it really shines. And then fast forward to today, we're looking at using machine learning and AI incorporated with that. So I talked about that overhead sign inspections, right? Yeah. Well, the piece I didn't talk about was they got the video, they got everything else. We saved that over $100,000, but the poor soul that had to be in the office watching the video of every rivet, right? The structure inspector. I'm like, I'm sorry. He's like, yeah, you can tell who's been flying because who was stable, who was zooming in and out, trying to make him sick. So that was the next piece. I said, let's see what we can do. So we're looking at using machine learning to let it do it to help save our poor structure inspector. So he'll train it once or twice to get that computer model going. And then let's let the computers figure out where the missing rivets are or any bolts and stuff, and use technology to do that instead and get even more efficiencies from it. And then our poor guy in the office isn't motion sick and everybody's wondering, why's that guy throwing up over there, right?
He's doing the rivet inspection.
Right. Whose turn is it this week?
So Paul, I have to ask you, you have a team of, 36 drone pilots, it sounds like. What does it take to get that job? Because I know so many viewers come to me and say, my dream job is drone pilot. What do I do? So
asking for a friend.
Right. What I would say first is get your license, right? Get your Part 107 license, and then start flying, because there's a lot of different areas to go. And that's the key. We're a little different in Utah, and some of my peers are the same way, in that we don't just do the Part 107 though, but we also have practical requirements. So I make all of my pilots go through practical classes and show that they can actually fly. And then we've got different classes. We've got a basic class just to make sure that they can actually fly. We do obstacle courses, other things. Emergency procedures are big in that. So I'll put the drone in the sky and not let them look at their tablet and be like, find it. So I'll have them turn around while I fly it out and say, I want you to be able to find it in the sky and fly it back without looking at anything. That way they get used to the controls, how they change, and what happens if your tablet goes dead. So that's kind of those key pieces, learn those practical skills. And then you get the more advanced ones. So like obviously bridge inspection is going to take a lot more skill than just doing mapping when you're just doing the automation software. But to get into it, I'd say start flying, get your license, just get a little bit of experience. And then that's kind of what you need. We've got all the pilots, but some of them, it's secondary to their duties. They just volunteered and wanted to use these because they see the value in them. Like our structure, it is fun. It's absolutely fun. When people hear that that's what you get to do for your job and you actually get paid for it, they're like, yeah, where do I sign up?
Right.
And you're seeing more and more jobs come out of this industry because of that. I'm sure all of you are seeing that. It's been great. And I think in the future, we're going to see even more. So,
what are there any unique challenges that governments face when it comes to implementing a drone program? And I guess, do you have any advice for somebody maybe in your shoes who wants to implement a drone program, but it doesn't really know where to start, or they're looking into the technology and trying to figure out where they can see some savings and where they can get value?
Yeah, absolutely. I'd say one of the most unique challenges that all of us have is perception, right? That's what we were talking about earlier, is let's get that positive perception out there, because when people hear you're buying drones, first thing they think is, oh, they're spying on us, right? Or they're just going to be doing something stupid. But if we can get that perception about what it really does and how we can save time, money, lives, all that, that's the key. And if you're just getting ready to start a drone program, I'd say look at what your real requirements are. People want to just go out and buy a drone, and they buy the horrible drone that's not going to give them what they want. So first of all, figure out what you need to do with it, right? Say, okay, this is my goal. This is my ultimate goal. Then start looking at what you need to meet that goal. So what sensor? That should be the next question, is what sensor do I need to obtain this? And then look at what drone can handle that. So maybe you need LiDAR, maybe you don't. Maybe you can get away with a cheaper drone. But I'd say look at aircraft that have a good record, that they're really easy to use, and not just easy to use, but you also have software compatibility. That's been a big piece for us, is the software compatibility of some of these. And don't always trust marketing hype too, because you'll hear that this thing can do everything in the world, and then you get it and it can hardly do anything that you absolutely need it to do. Maybe it can do everything indoors, but the second you get it into wind, it's worthless, right? So, or how long do the batteries last? So if they're trying to get into that program, really look at what their goal is and what they're trying to achieve. And also look at what budget they have, and also what limitations, because procurement's another thing. In government, there's a lot of red tape and checks and balances. So by knowing how to get through your procurement cycle is another one. There's some great resources out there. So Federal Highways, under their Everyday Counts 5 initiative, I sit on that committee. They've got a lot of great webinars and information that myself and a lot of my colleagues have been sharing. James Gray's heading that. That's a great resource too. I was on a committee for a domestic scan for NCHRP, and they actually created a document if you're looking to get started. It's called Successful Approaches for the Use of Unmanned Aerial Systems by Surface Transportation Agencies, and it goes through all that. So that's a document that's out there. It's NCHRP 20-68A or 17-01's report. So that's a way to get started too. But what I really like to tell people is you don't have to start and spend a lot of money. I mean, you're talking, you can get a high quality drone for $1,500. By the time you probably want to buy some batteries, get probably 4 batteries, get an iPad, get a good case for it. You're $2,500 and you can have a very viable drone program. You don't have to spend a lot of money. That will come with time as you build your fleet. But just to get started, you'd be amazed what you can do with some of these lower cost drones. You can do live streaming and get the data back to whoever needs to see it. You can do mapping, you can do surveying. You can do a lot of these things that I'm talking about with a lower cost UAS. So that's the thing I like to tell too. And just really start by what your goal is and go backwards.
Yeah, you guys primarily flying like $1,500 drones? Is it DJI drones? What are you guys flying?
Yeah, the majority of us are. We have a diversified fleet, so the majority of them are DJI, and the reason why is because those were the ones that were working the best at the time. They had the best software capability. And it took me a long time to find a good piece of software that I could use that actually did the terrain following, because Utah isn't flat. Some of the software that just is based off your home point doesn't work for me, because it will run right into a cliff unless I'm flying from the top of the cliff and then suddenly the ground sampling distance changes. So I need a software that will follow terrain when I'm mapping. That way it's following that consistent height above the ground. So that was a key piece too for us, is to find the right software that would integrate with that to make that work, or else our maps just weren't very good quality. Also being able to set ground control points and other things. So that's where it goes. But we can do all that with that lower cost drones. Now, if we're getting into areas with a lot of vegetation and we need to get data in there. So if you can imagine the old way, some of it was so thick, and I don't know if you know what Russian olives are, but it's the nastiest tree on earth, I believe. It's got thorns that are about 2 inches long. And if they scratch you, it burns for days. I mean, when I was first surveying through that stuff, I came out bloody and painful, and everyone was laughing at me. But it's not a fun thing, right?
Yeah.
But if you can do it with a drone or with LiDAR and let it fly it and get the data, it's much better, instead of having somebody crawl on their hands and knees through this stuff, trying to get a shot with a GPS when they can't see the sky, so they don't get a signal. With LiDAR, it can actually get through a lot of that vegetation. So if that's what you're needing to do, you might need to spend a little bit more money, but a lot of times to get started, you don't. You can do it with those lower cost drones, and that's the majority of our fleet really is those. We have some lower cost, we have mid-range, and then obviously the higher end ones, but that's because what grew over time for what we needed for our goals. We found out what we could do with the lower cost ones, and then when it didn't meet it, we'd try and see what sensor would meet those needs.
Awesome. Yeah, kind of debunking some of the myths that may be holding people up when it comes to implementing a program. So
yeah, the other thing I'd say too on there is, as I mentioned, the marketing hype. Understand what the real limitations are on that drone. And these are all from personal experiences of me flying them out there. We were doing a bridge inspection, and we had a really high bridge, 400-foot drop, right? And in the morning, it was great. Everything was going fine. I'm flying. Everything's awesome. And then the winds pick up. And luckily, I always save some battery just in case of emergencies. I don't take it to the end. So I was bringing it back when those winds came up. And here it is, like 10 feet away from me. If you can imagine a picture, here I am standing on a cliff. The drone's 15 feet away from me off the cliff. I'm full throttle. You can hear the motors, and it's not moving. And I'm just watching the battery level go down. And this was one of those ones that costed like about $40,000, right? This is an expensive one.
Wow.
And here I am panicking because it's like, some of it's made in flights. I'm like, this is not going to be a good day. And it would take me hours to get down to the bottom to even collect this thing. And here I'm like, oh, this was supposed to handle winds higher than this, but here we are. Right? So luckily the wind gusts died down and I had enough battery because of that reserve to get it safely back to me. But boy, it was a stressful moment for me. And I'm like, oh no, this isn't cool. So maybe I got to take it to the other side of the bridge and land it over there. It's things to think about when you're doing it. Get your policy and procedures. And in that, make sure you got emergencies in there too. Plan for those. I mean, you hope nothing bad's going to happen, but train on it and make sure that's not the first time that you've trained, because you want to be ready for it, not be like, oh, now what do I do? If you're already prepared, you've already trained on that, it's a non-factor as much, right? Because you're already ready for that. So that's another piece I'd say. When you're getting a drone program, make sure you get that. Make sure you get some policy and procedures down and train people the proper way.
So, but how do you test for that circumstance? How do you vet the marketing? That's another thing, because I have to say in the drone industry, maybe because it's emerging tech, there's a lot of overpromising that happens. So it seems harder to kind of get the right answer, even from well-established manufacturers, because they kind of always want to say, yes, this is good for that circumstance.
Yeah. Yeah, that's a very good point. And in the beginning, nobody else was really doing it, so I had to test that. And unfortunately, that's the way it was. But now I'd say talk to people. A lot of people are using these now that are out there, so there's some information you can talk to those who have it. Or if you can't, have the manufacturer come out and demonstrate it on site. That's another thing, especially when you get in the more expensive ones, because they may promise the moon, but then when you actually get some of that data, it may not be what they promised. So I'd say have them come out and demonstrate that it can do what you need it to do. And if they don't want to do that, then that may not be the platform you want to use.
Right. That's a sign.
So you're kind of an expert on UAS policy. So what are the kind of most important things that you'd like to see from drone policy over the next year or so? Maybe even 2 years?
Sure. Yeah, I see remote ID being that really big milestone for everything to integrate together. So next to that, I see BV loss, flights over people, and then also over moving vehicles is kind of a big milestone. Obviously, we need to get the redundancy and safety out there because there's just not a lot of data for it yet. It's getting more and more, and I think that's good. But on the policy standpoint, those are the big things that's holding everybody back. And a lot of those, I mean, there's a lot of obstacles to get that to happen, safety, but everybody's moving towards that. And as we mentioned before, aviation really has that amazing safety record, and we want to keep that good record of safety, right, with anything that's in the air. So I think really the big issues right there is defining the airspace too, and how all the UAS operations, including package delivery, aerial passenger vehicles, how all that's going to integrate together. And really what I think keys too is it's really important to get it right this time and learn from our past transportation mistakes that we've made in the past, right? So as I mentioned before, we're kind of working on that simulator with University of Utah to help answer some of those questions and see what happens with, as I mentioned, the vertiport in one area versus another area, or what does it look like with highways in the sky? How do you get an aerial vehicle or an aerial taxi with passengers on it up through the package delivery layer safely? How do those intersections work in the sky? And that's really what we're working towards, and what I see is the next thing that really needs to happen policy wise, and decide how that's going to work too. Are they going to let states help control the national airspace locally? Is it all going to be on the federal level? we obviously need that same federated system for a UTM to make it work, but who's going to control it locally? It seems like a daunting task for everything that happens within a city to be done on a federal level. So it may be a better place for states to help step in like they do with their local traffic operations centers. Maybe it's an aerial traffic operations center that helps that way. We're not exactly sure. We've heard a lot of talk about that possibly happening, and it's not been decided yet, but I see that as being one area that the states could help and maybe good at that, because they'll know what's happening locally in their community, maybe better than someone else. So it'll be interesting to see what happens, but I think those are the keys that really need to happen policy-wise to make this happen.
Well, any final thoughts, Paul, before we let you go? And then how can people get in touch if they want to ask any questions and just learn more about the great work you guys are doing in Utah?
Sure. Yeah, no, I just appreciate you guys having me on. It's great talking with Sally and everyone here, learning what everybody's doing. It's exciting for me. As far as getting in touch with me, you're welcome to emailing me at pwheeler@utah.gov. You can look at our website at utah.gov. There's a lot of information out there of what's going on through federal highways and other things, of what my peers and other states and I are doing. There's some amazing things going on right now. If you look at what North Carolina is doing, Ohio, New Jersey, states all across, Alaska. I could name all the states, and they're doing great stuff right now. And there's a lot of information. Federal Highways has been doing really good to get that information out, as you guys are too. I've been to InterDrone a few times, and it's great what you guys are doing for the industry as well. So I commend you on that.
Awesome. Thanks, Paul. Yeah. Sally, where can people find you?
You can find me at thedronegirl.com, on Twitter at thedronegirl, and Instagram at thedronegirl.
Awesome. We'll put all of that stuff in the description below the podcast. Thank you, everybody, for tuning in. Thank you, Paul. Thank you, Sally, for joining us. This podcast will be on the InterDrone website, SoundCloud, YouTube, Spotify, wherever pods are casted. So thanks again, everybody, and we'll see everybody next week.